entertaining.
Unless you're specifically interested.
Is on.
Are we live again?
I don't know. I hope so. I can't see the video.
Oh, somebody hear us?
And there we go. Yeah, we are live. Okay.
Hello, everyone.
Let me remove the last event that didn't work. Live streaming events. And then say, okay, everybody, welcome to the show, by the way. This is Mark. And Mark, this is also your friend Jeremiah. And you guys are part of a thing called Falcon Space. And you perform a bunch of research in anti-gravity. Did I get that right?
That's correct.
Yes, that is correct. We're doing research into anti-gravity. Right now, we're working on a couple different experiments simultaneously, and we're trying to provide to the people, what's going on and what works and what doesn't, along with theories and actual experiments. And I'm here at the lab. It's set up. It's in Hawthorne, New Jersey, in the back of a hybrid battery shop. I also work on hybrid batteries for a living. And let me just give you guys the tour and show you what's going on.
Excellent.
Okay, I'm going to toggle the camera. Okay, do you see that now?
Yeah. Immediately the NASA bag to trigger anyone.
Oh, yes. So what does NASA stand for?
I think it means to deceive in Hebrew, right? Isn't that Nasa?
No, NASA doesn't mean to deceive. It means to drive or whatever, to go places. But NASA, according to, who was that famous ufologist that just passed away? The name eludes me. Never a straight answer.
Oh, right. Absolutely. That's definitely what it means. Which, especially with that curved Masonic compass there.
Right.
But.
So it's very fitting that I put all of the anti-gravity related papers in the Never a Straight Answer book, because you're not going to get a straight answer out of that bag. Everything that's inside it is literally anti-gravity stuff. We got Paul LaViolette's book, Secrets of Anti-Gravity Propulsion, where he goes through just tons of different experiments beyond rocket propulsion. Oh, an etheric explanation. This is Paul LaViolette's shit. Gravity beam propulsion. This is the Podklanov experiment. And there's a chapter in here on microwave phase conjugation. That's an M drive. There's a paper here about the Searle effect and Townsend Brown, unconventional flying objects. I'm not sure if this is Townsend Brown, but it gets into Townsend Brown stuff at some point. And something that I thought that was interesting about Townsend Brown's paper is that he noticed that as you powered up the parallel plate capacitors, here's electrogravitic wave experiments. So as he powered up the parallel plate capacitors, there was an effect, and then it calmed down after a while. And I thought that was reminiscent of the pulse capacitor setup that Podklanov had, and that it had to do with the shape of the wave. Oh, here it is. The shape of the wave versus the type of wave. So it wasn't actually a sine wave or an AC wave. It was a pulse DC wave that I believe they were doing in the base of the ARV.
Can you try to bring your camera close to that drawing?
How's that?
Oh, there you go. You can see that. It's kind of interesting looking at kind of like a difference quotient and, a change, maybe even a vertex formula. I don't know. I can't tell exactly what I'm seeing.
Notice the asymmetry in the wave, too. The fast rise time, the slower fall time, once again.
Exactly, Jeremiah. That is key. The fast rise time and the slow fall time allows for a net force, net flux in one direction. This is one of the reasons why they call it the flux liner, because we're dealing with fluxes of energy. And to simulate that experiment, we have here parallel plate capacitors. We haven't finished building it yet. We need to
move your camera.
Well, something in your lab applies, Mark.
Move your camera up a little bit so you can show that thing a bit. The glass, copper. What do you got there? What is that crazy thing?
So basically, these are different sheets of copper with glass in between. We plan on putting some insulators in between it as well. And then we're going to pulse high voltage, probably on the small side of the capacitor plate, and charge it up rapidly and see if there's any gravitic effect. We can also apply the high voltage to the large plate and have this at ground potential and see if it moves in any other direction or creates a different flux, gravity, warp drive. Who knows what this thing works and how it works. In order to do that, we have a range of capacitors over here. These are high voltage capacitors. These are capable of going up to 45,000 volts at 0.01 microfarad. This one is a full microfarad, so it's 100 times more powerful. It has 613 joules, which for those who don't know, that's the number of commandments in the Old Testament of the Bible, which I found pretty interesting. Because all of this stuff connects to religion. I think anti-gravity is what got the Jews through the Sea of Reeds when they passed in the Old Testament. That was just advanced technology that made that happen. So, that's one of the reasons why I came to this. And to get a capacitor with 613 joules was really something.
Wow.
I also have barium titanate, which is sort of like a spice that you put inside of the capacitor that strengthens the overall power that the capacitor can hold. It acts as a dielectric, so you're probably going to mix that with some sort of material like epoxy. And to switch the entire device, to power it on and off, we have this Thyratron, which was removed from the Berkeley Labs linear accelerator, which actually discovered several elements, including berkelium, which is element 97 on the periodic chart.
So when did you get a CX1538? Where did you get that thing?
Straight off of eBay. They were selling all the parts on eBay, and I was looking at Thyratrons, trying to find like the most powerful one I could get. And this thing popped up, and I was like, holy fuck, that's exactly what I need. And then I was like, holy fuck, somebody else paid for this. This is like something that cost like $10,000 to create in the 50s when this was built, and only a handful of them were built.
Yeah. Arguably, it's priceless in a sense. I mean, it represents like the history of all civilization that was possible to be made. It's artisanal.
Yeah, but also it can switch thousands of volts, which is really what makes it spectacular.
That's absolutely true.
Up to 187 megawatts of power. That's like insane. Like, I don't even know how this wire can handle that, but it's only for a couple of nanoseconds that it does it. It's very, very short pulses. So if we charge up that big, this big capacitor over here to full charge, and use this to discharge it into these parallel plate capacitors, and add some barium titanate so the energy has somewhere to go. I think there's going to be some sort of effect. I don't know what's going to happen, but the only way to find out is to fucking try. So that's the goal. Fucking try it out, see what happens, and go from there. This is the control room of the laboratory.
Why don't you take a step back so you can see the whole shelf a little bit, see that whole area? Yeah.
So in the corner over here, we have a high voltage power supply that goes up to 125,000 volts. On top of it is a voltage divider, which divides the voltage 10,000 to 1 and sticks that energy into the oscilloscope that allows us to see the waveform of the high voltage pulses. So we're able to see exactly what's going on, how quickly it discharged, and what exactly happened on our high-speed oscilloscope, even though the voltages are that high.
Amazing. So do you have like a experience or where do you get your experience to play with these kinds of toys? Like, do you have a history of working with electronics or energy?
Yeah, so we have my basic job, my day-to-day job is working with hybrid batteries, which is the rest of the shop over here. You can see actually right next to our lab, we have a whole bunch of sorted nickel metal hydride modules.
Wow.
They're sorted based on capacity and resistance.
Hold on, wait, go back for a second. Go look at those. What? That's a lot of them.
This is nothing. This is, just from the last batch of modules that we ran.
So these are you use these. What do you do with these?
These are the modules that make up a hybrid battery pack of like the Prius or the Camry hybrid or the
So
GS450.
these are the fuel cells in these cars, basically.
They're not exactly fuel cells, but they are the closest battery to a fuel cell. They're actually very close mechanically to a fuel cell. A fuel cell combines hydrogen and oxygen to create water. This takes water and splits it into hydrogen and oxygen to store energy.
Oh, okay.
But it works on the same principle of a hydrogen fuel cell. These are cylindrical modules that are used in the Honda Civic hybrid. They have problems like with parasitic drain, so they need to be tested over a long span of time. This is a device over here that I built that tests the modules individually for their individual capacity. Basically has a temperature cutoff. As soon as they reach a certain temperature, they shut off and start
Whoa, is that
discharging.
Can you get a little closer to that? Is it a copper coil? I can't quite see it. How close is that? Tell us about what we're looking at right now. Get a little closer to that thing.
So this is a machine that I built. We call it the UBT, or the Ultimate Battery Tester, and it tests hybrid batteries in a full pack. And there's 3 computers up here that read the individual outputs of the individual modules, and each module has its own temperature sensor for charge cutoff. We know the battery is fully charged by seeing its rise in temperature. Here are some batteries that are waiting to be tested. And over here we have some more battery testing equipment. This device over here is another device that I built. It charges the batteries in series, so it like puts them all in a line, zigzagging back and forth, that the whole pack equals up to like 300 volts, and it discharges them in parallel. And while it discharges them, meaning this entire side of the battery becomes one solid connection. This is all done through relays. And the other side of the battery, each negative connects to each negative, each positive connects to each positive. And then we discharge the batteries using a grid tie inverter. So we're essentially recycling energy. So instead of turning that energy into heat, we just turn it into electrical potential in the grid, and our meter starts running backwards, unless we have something else running to use up that energy. Now, this is a rack we use to charge and discharge some modules. Can't fully charge modules in a rack. And this is a car that's in here for repair. It's a Honda Civic Hybrid. Over here in the corner, we have our high voltage test set up where we test entire batteries as packs. So you can see a battery over here on top of a pallet of other batteries. I have so many batteries, it's like not even funny. And here's some batteries we have in stock. You can see the Falcon Hybrid logo. Those are Generation 2 and Generation 1. Generation 1, 2, and 3 Prius. And I see Generation 2 and 3 Camry are in stock right now. And here in a quarter of the shop, we have Falcon Space. And Falcon Space is, literally dedicated to the discovery of anti-gravity. So I think it's like quintessential with all this going on with the Wright brothers. They had a bicycle shop and they were doing airplanes in the back. We have a hybrid battery shop and we're doing anti-gravity in the back. So it's a pretty interesting connection. Over here on the other side of this wall, you can see the high voltage power supply is over there. It feeds through this wall to this Faraday cage, which is the size of a room in itself.
Okay, so this guy's MTV Cribs episode has a Faraday cage. I forgot to mention that was coming. Yeah. Do you want to talk about how you have literally a Faraday cage?
So it's not just any Faraday cage. This Faraday cage is humongous. It's like you walk inside of it. I'm actually going to walk inside of it right now. I'm going to turn on the light a little bit. And inside this Faraday cage, you can see it's not complete yet. We need to put the inner lining on, which is something I wanted you, Andreas, to come down and help with. But
that sounds like a legit thing to do. I think getting involved with Falcon might be like the right move. Look at the Faraday cage, guys.
So check this out. There's individual capacitors placed throughout the cage, and this helps dissipate the energy as it's as whatever is happening over here happens. It'll send out some energy waves that we don't want interfering with our results, and we don't want to get irritated by. So we need to protect ourselves from the experiment. We need to protect the experiment from external forces. So that's why we built this Faraday cage. We want to be as certain as possible that whatever results we're getting from this experiment are real, and we're not dealing with known scientific explanations. This is the first setup of the gravitator that I built. I didn't do a perfect job with all of the goo on the side. I think that's silicone. There's some gaps in there that I could have filled in properly. And what ended up happening is when I power this thing on, there's a spark that jumps from here to here. So it's not able to reach the full 70,000 volts that we need in order to test this experiment. So we need to basically rebuild this thing from the ground up.
So can you talk a bit about why, okay, for instance, Michael Faraday built a cage and a cube. Can you use other shapes? Could you have a spheroid, or could you have a pyramid kind of? What other shapes can you use, and why is the cube so useful for the cage?
The cube is useful for a cage because just because of materials on hand, it's easy to build. Anything that is fully conductive is a Faraday cage, like an airplane, or anything of metal that is like the International Space Station is a big Faraday cage. Also, the floor of the Faraday cage is 1/4-inch sheet aluminum, and there is a pole. You can't see it right now, but in the center there's a grounding rod that goes down 8 feet into the dirt underneath this building that's grounding this whole thing out. And it gives us a really strong ground. We have a separate ground for the outside that it's a little bit over to the side of the cage. You can't see that as well. And that grounds the outside on a separate ground. So when we do these high power tests, we're going to use the center ground, the 8-foot rod, to ground out the experiment, because we're dealing with very high currents here, and you need to be able to dissipate that energy somewhere, or keep everything stable. Right now for this current experiment that we have, the low power just charge up of the capacitor, I have this high voltage cable coming in from the high voltage power supply. And that goes to this stick over here, which is made out of Teflon attached to a piece of wood, which is then attached to the ceiling. And then that connects to a really thin wire that transfers the electricity over to the gravitator device. And charging it up should create some sort of movement according to T. Townsend Brown. And if it does create some sort of movement, we're going to light an incense stick. You see, got an incense stick right over here. And that's going to show us if there's any ion wind effect, which is something you have to be careful about when dealing with high voltage. You might get ion wind and think you're seeing something else, but it's really ion wind. So we got to be careful about that. This black cable over here is actually a endoscope that allows us to give like a peek into the Faraday cage to see what's going on. I want to mount like GoPros maybe in the corners or something like that of this room in order to get it from all different angles, and really get maybe a high-speed camera or something like that inside the Faraday cage to see what happens when we do these really high-power pulsed experiments. To control the pulse experiment, this is the fiber optic cable that I made. Connects to the signal generator, and this side connects to whatever device we have in here.
My boy Mark making fiber optic cables for his Faraday cage.
Let's go outside the Faraday cage to show you all this. This is the entrance. Again, the Faraday cage is not complete. We still have all this aluminum over here that needs to be put on it.
What do you think about Mylar? Can you use Mylar in a Faraday solution?
It needs to be conductive. Mylar isn't.
Okay.
Mylar is conductive. It's just Mylar has resistance of per square inch something like maybe 95 ohms. The problem with Mylar is you can't really interconnect the pieces because making a surface connection is extremely difficult due to the fact that it's a glass with a metallized coating. So you're really much better off using something that's fully conductive through and through. Mylar also won't respond at all to low frequencies because, again, it's just a metallized film, and it's so thin and its surface resistance is so high that these low frequency waveforms just penetrate it as if it wasn't even there.
Yeah, I mean, we already have the aluminum. I have some thicker aluminum that we use for the sealing. We already have this material, so I might as well just use it.
Aluminum is a good Faraday cage material.
So is it also that it's a certain thickness because of the surface to volume ratio, so the thickness of the aluminum helps, or?
It's pretty thick aluminum. This isn't like regular Reynolds wrap aluminum. This is pretty thick stuff. I think it's around 0.5 millimeter or something like that. It's pretty freaking thick.
Excellent.
And to answer your question, yes, the thickness does help. The thicker it is, the better it's going to work. Also, the more conductive it is, the better it's going to work. The thickness adds to the conductivity. It's not that it needs to be thick to shield something like radiation as if there's beta or alpha particles traveling through it. It's that it just needs to have a very, very low resistance. And the lower its resistance, the more it's going to shield the electromagnetic field as they'll be absorbed and reflected by that material. So thicker material obviously is more conductive because there is a larger number of valence bands for electrons to fly down.
Perfect answer.
Another experiment that we're thinking of trying is the Alsaifan experiment. I think I gave you an introduction to that before. Let me pull it out of my never a straight answer bag. Here, Alsaifan experiment. Can you see this right here?
Absolutely. I was going to tell Brittany about this earlier because we call this lady who's part of the Secretarian books, and I think she's the only one I know might have this book besides you.
I mean, this is actually a paper that was written by Frederick E. Alsaifan, and it was published. It was peer-reviewed and published at the Joint Propulsion Conference in Colorado Springs, Colorado in 1981. So it's a peer-reviewed paper. It offers an alternative explanation to what gravity is and how to manipulate it with present technology, hence the name Antigravity with Present Technology.
So what is gravity to you? Or, well, am I skipping ahead?
What is gravity to me? The answer to almost everything is I don't know, but here's what I think.
Hmm.
That's
good start.
That's the way you got to look at this stuff because there's so much misinformation out there. You got to go with I really don't know. Let's try an experiment to figure it out. And according to Frederick Alsaifan, the gravitic field is a effect that comes off of subatomic particles. That they're not really particles. They're more like waveforms and that continue on into infinity. So every single wave has its precipice, and then it sort of mellows out after a very short distance, but it continues on almost for infinity. So every single subatomic particle is connected to every single subatomic particle. And because of there's a certain principle that, like if you had a ball of water in space and you split it and then allowed the two balls of water to come in contact with each other, they would form a sphere. Everything creates a sphere because that's the lowest energy state of the object. So the lowest energy state of all matter in the universe, because they're all interconnected, is a sphere or a single point. This is the force that we perceive as gravity, according to Alsaifan. And the way to negate gravity is to orient all of the subatomic particles in the craft to the same spin, so that there's no longer any randomness to them, and that will detach yourself from the matrix, where all these subatomic particles are all trying to connect with one another through this force we perceive as gravity.
This is something you were talking about earlier to me. I thought was like the only person I've met who really seems to think of gravity, or, well, I don't really, yeah, the way we have to spin gravity to be about waves instead of particles, and using vertex formulas, it makes more sense when you start talking about subatomic particles that are moving as you had a word for it, like they're
Coherent mass.
coherent mass, because things that are out of whack and they have different frequencies, and the subatomic particles are vibrating in different like gyroscopic motions away from each other that are kind of almost random.
Right, so it's the randomness that creates the inertial mass. That was another theory that I took off of Alsaifan. It's not exactly written in his paper. It was something that I made up. And it was just another way to explain away his results, because he tried this experiment, apparently, according to his son, who wrote a book about it, and it worked. He tried an experiment where they did dynamic nuclear orientation to a aluminum sample, and they had an 80% reduction in weight. So we're trying a similar experiment here in the lab. Jeremiah is going to help us by creating a very laminar magnetic field, and we're going to stick the aluminum sample in that and then hit it at the Lamour frequency of the precession of the electrons, which is correlated to the magnetic field, which is why we need a very laminar or steady magnetic field. When you hit when you hit it with pulses at the Lamour frequency or the precessional frequency of the subatomic particles or the electrons get a little energized and transfer some of their orientation to the core of the atom, which in turn disconnects it from the gravity field and possibly negates its inertial mass. My way of looking at it was that it's negating inertial mass, therefore it's disconnecting from the gravity field. Alsaifan's way of looking at it was, no, it's disconnecting from the gravitic field by creating some sort of shielding effect, and therefore it might lose inertial mass.
There's a lot of people. Sorry, go ahead. Sorry.
Because we know inertial mass and gravitic mass are one and the same. We've never seen any instance where gravitic mass and inertial mass didn't match each other.
That is entirely not true, Mark.
Really?
Gravitic mass and inertial mass are significantly different, and there are many examples of exactly this. Even Boyd Bushman talks about this simple experiment with some neos and dropping them inside of a bored-out rock.
And water, too.
And seeing which one hits the ground first, and he demonstrates the two neodymium magnets pushed together with pole spacing and sandwiched completely tight fall slower than the rock alone, even though they both have the same mass.
That might be a frame dragging effect. It's not necessarily anti-gravity.
It seems like it might be, though, of like a vertex function of the torsion. So at certain moments, because there's an electromagnetic field, there's going to be a frequency that holds things together in the way we're experiencing things. But for instance, if things were changed, if you had a different, like Tesla was talking about, different electromagnetic fields, that would affect the frequency, and that would also affect the weight of an object. So gravity doesn't always work the same depending on different. I mean, you use sound waves, you can levitate things.
He was talking about the Boyd Bushman effect. That was one of the experiments we actually set up to try. I got these two magnets. Right now they're not in opposition, but you can still see the frame dragging effect that I talked about. These two magnets are very powerful neodymiums, and we use this rod to force them together, even though they were pushing against each other. And I never dropped it because these magnets are pretty expensive, and I don't want to break them. And we need like a proper testing rig to see if anything was going to happen anyways. But you can see, I don't know if you can see it on the video, but I can feel the effect. As you move a piece of copper through the field, you can feel a resistance to movement, which is what I'm talking about with the frame dragging effect, because anything that has electrons in it, including the air, the electrons get oriented and reoriented as the magnet moves through the material, such as air or even the ether. So if you're moving strong, powerful magnets that have strong magnetic fluxes or changes in their intensity or direction as in a very tight area through any such object, especially copper, because copper is extremely conductive, then you'll feel some sort of frame dragging, and the object will fold slower. I don't think that's an instance of inertial mass and gravitic mass not matching up. I think it has more to do with frame dragging and than any other effect.
Well,
I may be wrong. We have yet to actually try the experiment, though.
Copper seems like, as an insulatory material, if you were to connect it to some sort of electrode, and you then be able to have a different field, then you might also see like a different effect, like of the electromagnetic field being, turned around. If you're able to change the polarity just because you had electricity going through it, so maybe it'd be something like radio. It's a radio magnetism.
I'm not really sure. Here, check this out. I'm going to drop this piece of copper next to it. You should be able to see some effect. There, it caught onto the magnetic field lines and tried to follow them. The natural way to follow them would have been like this. And I don't know if you have a way to slow down the video, but you can see I dropped it perfectly straight, yet it hit the lower magnet because it got pulled inward by that force. So I'm going to drop it again. You can see it pretty clearly there. That is called the Boyd-Bushman effect. Here's another example of this effect. We have a piece of copper on the table, and I'm able to, without actually touching it, I'm not touching it, I'm able to drag these pieces along. Can you see that?
Totally. So you're adding, so it's all through the insulatory material still becoming magnetized, or how would you describe?
How would I describe it? So what is magnetism? Magnetism is the orientation of the spin of the electrons. So basically on these magnets, think of it as there's a line going from here to here, and that is basically a circle, not a perfect circle. Depends on many factors, including the magnet that's right next to it. And that is the orientation lines of the electrons. The electrons are being oriented on those lines. So when you have a material that basically has a high conductivity, that means that the electrons between the different atoms are fluidly allowed to move around. And when you move an object through a field like that, you induce a current, because now the electrons are being forced to move around and change their orientation in order to keep up with what the magnet's field is putting out. So that in turn creates an electric potential, which gets shorted out by the solid piece of copper, which in turn forces some sort of frame drag or braking effect. If you continue to move a piece of copper up and down next to the magnet, even though you're not touching it, you will create heat inside the copper specimen. This is the same way that electric motors work. They just have, instead of a solid piece of copper, they have windings of copper, and they use that potential energy, that created energy, by moving it through the magnetic field to create a pulse of electricity, and they do it 3 times, 3 separate coils. You have 3-phase electricity, and they feed that over wires from the grid, and that's how I power the lab, at a local nuclear power plant.
That's so unbelievably America.
That is what we do here in America.
So what is it exactly that is the point then of this lab? You've got this crazy setup. You've taken all this technology. You've been working with batteries and turning them into super, better cars and things. Like, you want to do something with anti-gravity. What is it that you want to do? What is it that you want to understand?
I want to understand how it works, how flying saucers work, and go and build a flying saucer. I'm tired of working on hybrid batteries all the time. This is old technology. I'm just making a internal combustion engine slightly more efficient. I want to do something different. I want to actually build spacecraft that can go to Mars, that can make us interplanetary or interstellar civilization. And this is the way to do it. It's not through rockets. Elon Musk should be listening. Rockets are not going to get you to Mars. I mean, they can land a little lander there, so be it. But if you want real civilizations on Mars, you got to go with anti-gravity. And if you want to go to the stars, there's no way in hell you're getting there with rockets. No way in hell.
Well, it's funny. I think a lot of people would agree with you about that. At least no one's getting there with rockets. The thing about anti-gravity, though, like you think that it could be very useful here. Do you think that these kind of crafts will work in our own atmosphere? And do you think they've already been made by some companies or governments before?
The answer is yes, yes, and yes.
Well, go on.
Okay, so a lot of weird anomalous effects have been observed by companies and individual researchers throughout the ages. Actually, since the early 1900s, even Tesla mentioned other weird anomalous effects. So there are quite a few pieces of history that talk about electrogravitic effects, and they go way back to influence machines. Some of the earliest research of electricity in general, where they were just purely electrostatics with almost no current. You know, objects levitating and that sort of stuff. I actually have this old book called, I think it's like How to Build Your Own High Voltage Generator or something like that. And it showcases an experiment with this wind source machine that was built by a researcher back in the late or mid 1800s, something like mid or late 1800s. And he fills this chamber with pressurized carbon dioxide, and it allowed him to run the wind source machine with a significantly higher voltage because he didn't have breakdown between the plates. So he has a small 1 centimeter wide sphere, approximately 0.2 grams, and it would levitate between a ground plate and another sphere approximately 2 feet away from the ground plate. It's probably ionic. He did mention a bluish aura coming off of the high voltage terminal directly out of the wind source machine that was under pressure and CO2. So I'm guessing that it was just like an ionic wind type of thing, but it could have been somewhat electrogravitic nevertheless. And it would be an interesting experiment to replicate, only we don't need to build a complicated mechanical device that has spinning plates. We can just use a voltage multiplier thanks to, you know, the wonders of modern day conductors and dielectrics.
That's so balls deep. Man, that's so good. That's exactly what everyone wanted to hear. You have no idea.
To do that, I'll grab it.
Well, he's going to go grab something I was going to say. Isn't that exactly what we've been studying about Delft? All right, here he goes.
It's band light. Full frequency. There we go. Okay, if the camera can compensate for the light, which it doesn't look like it much likes it. So
Tell us.
that is a 500,000 volt multiplier. Each of those stages, each of those two capacitors you see across from each other is a 20 kV stage. So the input terminals are on each side, and I guess, yeah, here you can see it in the reflection. So the negative, I can flip this thing around in the base, and depending on which way I stick it into the base, I can have a positive output or a negative output, and this will reach 500,000 volts potential. And the crazy thing is how small it actually is, because normally a 500,000 volt machine would be huge, you know, several feet tall, gigantic insulators. But this particular one is pretty darn small. And so that's one of the things that I'm working on. It needs to be rebuilt with a larger amount of space for insulation, and I'll probably use some kind of high voltage gelling material with another high voltage insulating material similar to what they use in the semiconductor industry inside of IGBTs to hold the gate wires in place. It's like
That's really,
but it works real good for high voltage anyways.
I don't know if you've seen like warp, which is like kind of like not like warp, but it's warp is wireless ambient radio power. And so basically using like aerial antennas, you aim them at a television radio signal, and from the TV station broadcast, you get enough electricity to power devices. It's only a little bit of power, but if you look at 5G, like it's pretty easy to see how you could put a lot of power into a small place, and you can power that kind of crap.
We did that with the Tesla Tune receiver, and we were able to draw small arcs off the top from the local station that was like 7 miles away.
So you were getting power from TV station.
Power, more than enough power to light up an 8-foot fluorescent tube 24/7 from the radio station.
My guy.
Is that crazy, guys? I'm going to take a hit of my green tobacco here.
Yeah, sounds good. I didn't see a thing.
That's straight up. That's some Rogan moment. Well, you know, that's they believe in space. Like it makes sense, right? So that's another thing. When that guy gets back, I'm gonna troll him super hard and ask them about flat Earth because it's time. Because you know anybody who believes in space this much, I think I owe it to the flat earthers. But also, I want to ask a bit to Jeremiah.
Yeah.
If you're hearing me, a little bit about ionic lifters because
I can tell you all about those and all day long.
I'm a huge fan. I grew up playing with them. My grandfather played with them. Actually, if you saw that switch from Berkeley Labs, my grandfather worked with like a bunch of. He looked for Lockheed and did some of this stuff.
Really?
Yeah, so I'm pretty interested in ionic lifters
tell me
because I knew
more.
when I was a kid. I think that they have existed for a long time, and I've been making this series, and that's actually right before I brought in Mark, which is kind of about the history of wireless crafts. And NIMSA and Delshau and gas Zeppelins, like Led Zeppelins that are electromagnetic. So I kind of wonder, like, what do you think in general about the history of flying saucers? How far back does this go? Do you think humans were making them? Like, what do you think about all this stuff?
Well, I've got what I know to be true history, I have what I know to be speculative history, and then I have what I have no idea could be early history that's more folklore than anything. But I consider it as a plausible possibility. So things like Vimanas that we know go back and are dated at least 6,000 years or more, Hindu and Vedic traditions. Many flying craft have been talked about throughout history, and pretty much all the visitors, even those that were mentioned in the ancient Sumerian text, which the most recent of I think are like 6,000 years, and the general mass of that, which is thousands upon thousands of pieces of artifacts that are over 12,000 years old, and they talk about the visitors from the sky and the flying craft. So somebody made these artifacts. Somebody seen these beings from the sky and had knowledge of our place in the solar system and knowledge of our star system in comparison to other nearby star systems, which is pretty fantastic. So I don't know. I don't know really whether or not the characters described by these very ancient pieces of history and artifacts that we found are actually describing visitors from another place, or they're describing human beings who have achieved an incredible amount and are almost otherworldly and described as visitors almost because of that. But whatever the case is, I do personally believe, and this is just my opinion, that human beings have been flying around the skies of Earth for a very long time.
Did I?
Hey, Mark, you're muted.
Did we fix you, Mark? Mark, can you unmute yourself? Try to unmute yourself. There you go.
Can you hear me now?
Yeah.
I have chemically pure mercury, 1 pound. I actually have a couple pounds. This is just one bottle of it.
Wow.
And this is for trying the Vimana experiment.
Wait, is that really 1 pound of mercury in there?
Yeah, there's 1 pound. Here's another pound. Got a couple pounds of it.
That tiny little thing is what? Wow.
That's not quite heavy metal, man.
Wow. Okay, so that's Okay, so if that's 1 pound,
It's very heavy.
That jar I got, it's got to be like 28 pounds.
By the way, Jeremiah, that was an epic. There's an epic intro to Vimanas. There's a lot of stuff that I think that we would agree upon on a lot of that. So that's awesome.
Hey man, I gotta send you T.T. Brown's drawings for a mercury vapor generator.
Yeah, looking into liquid mercury. I mean, like a lot of us. I was just on a radio show today where we talked about liquid mercury being used in like huge amounts to go around buildings, and to be powering systems like by having rivers of mercury, but also how you could use that in like liquid circuits.
Well, the liquid mercury is great, but the real magic of mercury comes into the fact that it can be ionized and produce a vapor. That vapor can accelerate to a very, very high velocity. And here's the thing with a vaporous massive particle, something heavy like mercury particles. When they get going real fast, if you can accelerate them under a high enough voltage field, as they accelerate and gain velocity, they experience an increase in their relativistic mass. So you can push against that increase as they accelerate and use the fact that they are not traveling within the same space-time reference as a craft, and they become a virtual space-time reference, distorting the field around them as they travel. And so because you can push against them, you can create an asymmetrical force and create thrust without a reaction force.
So do you
guys, check this out. 1 second. He just mentioned something. I got to show this to you. This is a Mercury tube. It does something similar to what the Thyratron does. It allows you to switch on and off energy, but it uses Mercury instead. And the good thing about Mercury is that it has very sharp impulses. It creates very sharp impulses of energy. It's not capable of the wattage that tube is able to put out, but it is able to put out very sharp edges of energy. And I plan to try this tube as well to see what sort of waveform it gives, and if there's any real benefit to using Mercury in such a setup versus hydrogen.
Tubes are great. Tubes are great for switching. Let's see here. 10. Yeah, that would give us 0.26. Yeah, 260 milliohms. Okay, yeah, tubes are great, but the only problem with them is that they have a really high turn-on resistance. So even when a tube is fully conducting, such as a Thyratron, like what you have, you're still talking about hundreds of ohms or kiloohms of resistance. And a lot of power can be lost in that, and it also equals slower rise times for capacitive loads. So Thyratrons are great when you're switching into inductive loads because you don't have an immediate rise on your voltage, and it just has to be present in order for the electrons to start to flow. But with capacitive loads, it's like a direct short, and the more current you have, the faster you'll charge it. And that's really where T.T. Brown stuff requires a direct transformer output, more so than a soft switch. So, and I've showed you this, Mark, but I haven't showed everybody here. So this is a alternative to a Thyratron, and something that I'm currently developing.
Jeremiah, what we were trying to do with the pulsed capacitor setup was try, first of all, just the high voltage, zero hertz, and see what that does, and then move on to actually pulsing the energy with different waveforms and see what that does.
You're going to need really fast impulses, though. You can't simply turn it on and off and depend on the leakage current of the capacitor to drain it.
Yes, so we're gonna it's gonna be like a one pulse experiment sort of thing. Then you have to discharge the capacitor slowly.
Well, all you've got to do is place an isolated transformer, a pulse transformer, in series with your high voltage supply output, giving the capacitor an instantaneous high voltage pulse from that transformer with a fast rise time. Something with a fairly low impedance and a high primary current in its tank circuit. And that will provide you the necessary asymmetrical impulse that you need to make that thing actually do something.
Yes, but we were thinking of using a capacitor to charge a capacitor and use a Thyratron in between. I think that is the way to create the strongest pulse possible.
Yeah, it should be fully capable of handling the current once it saturates. I know
right.
The rise time is going to be faster than any semiconductors, that's for sure.
Right, so that's why I was thinking of doing that, and I was also thinking that it's possible that the mercury vapor that was in the monocraft were doing the same thing. They were acting as basically energy switches to pulse these capacitors. And don't forget, capacitor in Hebrew is the same term that's used for the Cabal. Cabal in Hebrew means capacitor. And it's really strange that there's this group of people that are trying to keep this whole UFO thing a secret, and they call themselves the Cabal. And Cabal in Hebrew is actually capacitor. So maybe that's the entire secret to the ARV, the Alien Reproduction Vehicle, where they called it the flux liner. What's a flux? A flux capacitor. We need to flux the energy that goes into the capacitor in order to create this effect. So I think there was secrets and little breadcrumbs that were hidden throughout as they built this thing, just like the name itself, flux liner. There's something to be learned from that.
So is Kabbalah related to capacitor, or just Cabal?
So Kabbalah means like to receive the hidden knowledge, like Kabbalah, to accept. Kabbalah at its core means to accept. So what is a capacitor? It's an acceptor. It accepts energy. It takes on energy. Hebrew as a modern language is a very primitive concept. So to accept the hidden knowledge and to accept the energy are both used the same for the same word, the same root word. If you put them together, though, it's to accept the hidden knowledge about capacitors. And the hidden knowledge about capacitors is that they are flying saucers. That's at least one theory. Another theory that Jeremiah put out, which I found very interesting, is that what they actually are is M thrusters, Q thrusters. A Q thruster is similar to like the M drive, where you are turning one form of energy, like electrons, into another form of energy, like electromagnetic waves. So you're going from a particle to a wave. And when you do that, you're taking all the electrons from one point, shoving them in another direction. That creates a thrust. Then you're expelling them as these electromagnetic waves. So basically, that explains why getting close to a flying saucer is likely to get you radiation sickness. It's because it's radiating all these electrons that are really they're like rockets. They're like electron rockets shooting their
huge
energy
amounts of volts per meter. I mean, we're talking megavolts per meter or more.
Who knows how much? But they're pulsing this freaking energy out of the craft to create a little bit of thrust. And I think in the core of the craft, you have like an inertial dampening device that that basically negates the inertial mass of the craft, so that it can fly along using very little thrust.
So what's the M stand for as opposed to quantum and Q thruster?
The M drive is the device. It's being built and studied by NASA right now. It was invented in 2005 by Robert Scheuer, and it is a proven Q thruster. Sony White from NASA is going around doing speeches. You can see them on YouTube, where he talks about all different types of Q thrusters. And I think Jeremiah, in a past video, convinced me that it's possible pulsing a parallel plate capacitor would create some sort of Q thruster, where you're pushing off the quantum background.
Absolutely. You do need to introduce an external magnetic flux to orient the electron spins within the place of the capacitor so that they have something to push against.
No, you're conflating two different things. One of them is an inertial dampening device, which is the Alsaifan experiment. The other one is the pulsed parallel plate capacitor experiment, which is more T. Townsend Brown's work. There are two different.
Are we not talking about T. Townsend Brown?
There are two different experiments working together to create this effect of a flying saucer.
Well, yeah, you need to introduce two things. You need to introduce the fields, and you need to introduce momentum. So that momentum can be an asymmetrical charge, either entering or leaving that capacitor, or it can be a static charge across the capacitor and an asymmetrical field that surrounds it. One way or the other, you have to create the asymmetry in order to introduce electron momentum. Otherwise, you have no net force.
Yeah, the key is asymmetry. So we have to try different methods of asymmetry and see what happens.
Right.
It's interesting that you're using real experiments instead of just messing with virtual models, because I think most people aren't doing the actual work to experiment.
Well, we can play with models all day, but there's no saying that the programmer knows every single parameter of physics. I mean, right now, if physicists aren't already finding these things in their lab experiments, we have to imagine that one of the reasons might be the models are wrong. And if the models are wrong, we have experimenters that are observing things that just simply don't fit into the mainstream, then no matter how much we try to model things on a computer, we'll never see these phenomena.
How wrong do you think they are?
How what?
How wrong do you think the models and the science today?
Barely wrong, just enough. It's okay. So it's the lack of recognition that space is not the same density everywhere you go. Light changes speed all the time. Traveling from where you are to where I am, if there happens to be a mountain range between us, light's going to slow down as it traverses the sky across that mountain range because there's more mass there. That fact is something that's kind of interesting, because right now we consider it's the gravity of the mountain range that is causing the light to slow down and bend towards Earth more in that area. Even though light has no mass, it's attracted to the gravitational field of the Earth. Supposedly because time is slowing down, right? But what's really going on is light's an electromagnetic wave, and an electromagnetic wave only knows one thing, and that's the polarity of the space around the traveling wave. So if that space is neutral, then the wave will travel straight. But if that space is more positive on the top side of where the wave is traveling through, and the bottom side, the wave is going to travel based on its polarity towards one, charge or the other. And if there's a moving charge, the wave will be diverted again. So this is something that's utilized in phased arrays, where we take multiple antennas, we run them simultaneously with each other, and we line up based on the velocity of light the various intersecting waves to either create a very strong wave with a high amplitude or cancel out other waves from the other side. And we can steer waves this way. It's used in radar and Lidar as well. But ultimately, what we're really doing is we're understanding that space has a finite ability to hold an electromagnetic field. And the more power we put into space, the slower light travels through that volume of space. It's not the gravity of the mountain range that slows down light. It's the fact that all the atoms within the mountain range contain these little electrons, and Can
you say that again? Can you repeat the speed that they're...
Yeah, so as far as gravity goes, the reason why a photon bends and it's traveling over a mountain range and travels slightly slower than if it was just traveling over flat ground that it was a farther distance from isn't because that mass has some kind of gravitational potential that slows down time. It's because the individual electrons and protons that are in each of those atoms composing the mountain range are in motion constantly. And as they move, the Lorentz transform tells us that they are transmitting an electromagnetic field out into space. So as an electron makes its rotation around the photon, it's losing energy. And that energy is going where? Well, it's going out into space, and it's spreading out, getting weaker and weaker as it travels away from the valence spin. So gravity is the fact that there's more electromagnetic density in one volume of space than another, and the photon has to traverse the greater amount of electromagnetic density caused by the electron spins and the proton vibrations within all the atoms of the mountain range, and as a result, it travels towards the area of highest density, wherein the path that it has to take from point A to point B is the longest electrically, as far as the photon is concerned, because that area is saturated with tiny little ripples and fluctuations that are traveling through. So it doesn't just take a straight line. A photon will, take a ripply little kind of swirly line moving around all these electromagnetic fields. To us, it looks like a straight line, but if we were to look at it at, one momentary time and just watch it frame by frame from the Planck length, we would see it moving around and kind of jiggling, following these electromagnetic fields as it moves.
It looks like, is Mark trying to say something? He's muted. Mark, if you're muted, you might need to unmute.
Yeah.
And
okay,
yes, and by the way, yes, Rogue Code, we are talking to some people that they are geniuses, but they happen to believe in space. That's true. And I think we can address that in a minute. Because I want you to know, some of the people that are watching are like flat earthers. So I'm kind of curious, this particularly, because I already heard Mark, and I want Mark to go on, but I also want to hear Jeremiah really quickly first. What do you think about flat Earth? And do you think that, have you seen the maps of like the ancient world, how everyone used flat Earth, and all of a sudden NASA's the first one not to use the flat Earth map? And do you think that there's any sort of metaphysical quality to it that's useful? Are you there?
Hell, even in the Bible, which, is a 2,000-something-year-old Roman book, you have mention of a round Earth. It's been known for a long time that this thing we live on is round. You can look out into space with any arrangement of lenses and see that everything else is round, so why do you think you're special? I think that the notion of flat Earth, and this will offend some of your crowd, is quite frankly ridiculous and completely unmerited, and experiments prove this time and time again.
We just saw the transit of Mercury, and I saw it through the telescope myself. I actually have pictures of it. It's real. Mercury is in front of the sun. I've seen the transit of Venus as well. Every single planet in this solar system is round. Every single star we see is round. Round objects form in space all of the time. We see it happening with a ball of water in the International Space Station. What you see is it becomes a ball. Even if they perturb it a little bit, it goes to its lowest energy state, which is round, which is a ball. We live on a ball. I think it's pretty obvious. But I think in order to be a flat earther, you need to have a very open mind. And I think that's where what we have in common is that we have very open minds. But like, don't be so open that you don't realize that the world is round. And there's a lot of evidence for it.
As they say, don't be so open that your brain falls out.
Yeah, don't be so open that your brain falls out. Now, getting back to the actual science, what I have here is a very asymmetric capacitor. I'm thinking instead of using the glass, maybe I'll mix together some epoxy and throw in the barium titanate from over here and try to like figure out where the optimal setup would be to make a high voltage capacitor that will allow us to do both the high voltage setup, just applying a high voltage, and also the high voltage pulse setup. Hello?
I think we just lost Jeremiah for a second. I still see you. Hopefully we'll be able to pop back on.
Oh, I was hoping Jeremiah would
There he is.
go into this. Oh, Jeremiah, you there?
Yeah, sorry about that.
So
Oh, you look like way better quality though. Thank God.
Oh, that's
you did
weird. Well, cool.
by the way, how are you guys seeing this this stuff on my table? Are you seeing it clearly?
Gorgeous. It looks like a futuristic record player from like Cool Running or Silent Running or something.
So imagine if we applied ground potential to this, and to that we applied 100,000 volts. And we had a whole bunch of barium titanate inside of epoxy in between instead of the glass. What do you think would happen, Jeremiah?
Well, I think we would get a thrust if we provided it with the right types of input waveforms. And obviously we're working on something similar because here we go. And so I've showed you this, Mark, but obviously the audience has seen it. So
I can't see what you're showing me right now. Just so everyone knows, my camera's fucked up, so I can't really see what's going on. So everyone needs to explain to me what they're showing.
There are two discs, very much like what you were looking at, only instead of a piece of glass between them, they're on a sliding rod that can be moved away from or towards each other, varying the capacitance between these two pieces. So all I have to do is stick a piece of dielectric that's shaped correctly between these two pieces, and I will be able to give it the high voltage pulse after polarizing it with another DC voltage, and I should get the thrust that I'm predicting based on DC ground stuff.
If you want to increase the power of the dielectric strength, you have to increase the air dielectric strength.
Well, that's why I need to get rid of air, and again, that's why the titanium dioxide, because I can fill that with fill this stuff into epoxy, mix it with part A and part B in high ratios, and then I can create my shapes dielectric with a high K of titanium dioxide, and that should do the job.
I want to try that with the barium titanate. What kind of epoxy do you use?
I've been using wet systems, but I have a special epoxy that's produced by, I can't remember the name of the manufacturer right offhand. It's specifically made for high voltage potting of electronics and transformers.
Oh, so this is something I would have to order special. I can't buy this at Home Depot.
Yeah, Smooth On, that's who makes it. Smooth On has a special product that's made for that kind of stuff. And they have two versions. They have one that's like a black, and they have one that's an ultra clear that is semi-UV resistant. The only problem with it is that it is a heat cure, so you have to have a curing oven. I ended up buying a small toaster oven and modifying it with a temperature controller and another circulating fan so that I could use it as a curing oven, and that worked pretty well for most transformers. I did have some epoxy curing issues early on with it, but it works real good, and that particular epoxy is nice because it's a good insulator, but it doesn't respond to high frequencies very much, meaning that even when you have a fast transient traveling through it, there's not much of a conversion to heat. Whereas the West systems and other epoxies, especially like your 5-minute and 10-minute hardware store epoxies, those are going to have a really high response to RF frequencies, even in the megahertz range. and you will definitely see the propagation of heat through those materials, and it's an undesirable effect that decreases the dielectric K by increasing the randomness of the atomic motion within those samples.
Okay, so if I'm understanding you correctly, you're saying the 5-minute epoxy will work well for low frequencies?
Yeah, it works real well for low frequencies, and it's a good DC dielectric. It's just a really poor AC insulator.
Oh, okay. We're trying pulse DC, and it's pretty low frequency, so I think the 5-minute epoxy then will work, right?
Well, you've got to keep in mind that pulse DC, if it's a square wave, still has one important part of the wave. Really the only important part of the wave. It's the transition from one voltage to another, so either going from ground potential to high or high to ground. And during that point, you do have a very, very fast transient, and that will be the same as a high frequency traveling through that material. So if the material eats everything, say above like 2 megahertz, and it increases by 6 decibels per octave, then by the time you get to like transients in a few nanoseconds, you're going to kill your signal completely.
Right, and is this what people are talking about with scalar waves? That when you have a high pulse, a very fast rise time and a slow drop time on the I guess you call it a triangle wave or something like that? No, it's more like a
yeah, it's like a saw wave more than anything.
It's like an inverse saw wave, like a leaning saw wave.
Right, and based on the slope of either the leading edge or the falling edge, you have your total amount of power asymmetry.
Is that what we're talking about with a scalar wave?
Yeah, we're talking about that differential between the local volume of space going from one electric potential to another. So if you have a volume of space that has a potential that's, say, negative 100,000 volts to ground, and it changes to positive 100,000 volts to ground in 1 nanosecond, and you figure out how far light can travel in 1 nanosecond, then you know you have a differential of 200,000 volts per that distance that light travels in 1 nanosecond.
One of the questions we're getting right now from the live YouTube chat is they're saying,
where is this live YouTube chat? I should be watching that.
Yeah, right? I know. I'll send you a link to it. I'll send you a link. I'm sorry.
Sorry, I didn't even know we were on YouTube. I would have been watching that chat and answering people's questions.
Yeah, my bad. I'll send it to you right now. He says, but I'll say it while I'm sending it to you. Scalar waves, they said they didn't think existed. This is scalar is a wave, like saying wave. Wavelength and distance of reflection. I don't know. That's kind of an abstract. What do you got out of that? Is scalar a kind of wave or is
it on the YouTube chat so I can read it myself and
all right. I'm working on it.
How
do I send? I'll put it in the you know where you commented when you got in here?
Yeah.
There we go. Well, here you go.
Jeremiah.
Right there.
What temperature does the epoxy cure at?
It's
best conversation about epoxy I've ever been a part of, by the way. This is epic.
It's probably the only conversation about epoxy ever.
No. I roll pretty deep. I used to put epoxy with batteries and LED lights and stick them to walls for a day.
Sorry.
I need epoxy for life.
I had to mute the YouTube thing that was planned.
Andreas, you want to come down to the lab and play with epoxy with me?
Yeah, LED light bulbs and epoxy and the Faraday cage. Those are the rules for a good time, I think. Do you ever just hang out in your Faraday cage? Like, do you just like listen to music in there, play guitar? Like, do you ever just have a chill meditation space? You know what I mean?
I really got to finish the Faraday cage before I can do that, but I would imagine it would be a very great meditation space because apparently Faraday cages or these metal materials also block out other people's thoughts. A lot of people that are very intuitive can't listen to their own thoughts because they're busy hearing everyone else's thoughts and like making it their own. So being in a place like that would actually be pretty beneficial. This is according to, I got this from, what's his name? Billy Meyer. I think Billy Meyer is the real deal. And I read a book about Billy Meyer that was debunking him. And that's what convinced me that it was real, because I could see from the author that he wasn't being honest, he was writing this book with just the intention of disproving Billy Meyer. He went to the limit of actually trying to fake the UFO pictures by making models of the UFOs that were in the pictures. And then Billy Meyer was then pictured with those models later on. This is years after the pictures were taken. So everyone assumed, oh, he faked it all. But no, something really happened there. And one of the things he talks about is a sort of Faraday cage made out of copper that they would meditate inside of. And they did it for this exact purpose, to stay away from other people, to try to like grow spiritually. I think that's what the pyramids are. The pyramids are a Faraday cage. You go inside the king's chamber, which is the center of the Faraday cage, in the most opportune spot to not listen to other people's thoughts, and you meditate in there. And the craziest thing is there's a tiny hole that goes all the way out and faces the Pleiades during the equinox. So if you're in there meditating, you could literally communicate with the Pleiadians, which I think is insane.
Well, if you, or just earlier, Jeremiah was bringing up Lidar, and I've had a long belief that Lidar has existed in nature, that stars could be used to send information. The luminaries could literally just be using Lidar. And then these crystals could be used to arrange into a sort of radio receiver that would eventually allow for DNA to start some sort of a sequence. So it goes noosphere, geosphere, biosphere, noosphere, repeats, So I think Lidar could be part of nature. And the Pleiades would be, the source of that. Pretty clearly.
You lost me there. What is Lidar?
Lidar...
Okay, go ahead.
No, please. I'm so sure you're better at this.
So Lidar is a ranging device that uses light detection, and so it uses light. Light isn't just the visible wavelengths that we associate with our vision. This is sometimes very long wavelengths that are generally considered radio frequencies. But these would detect how materials can reflect that particular photonic range, and using different wavelengths, we can detect different size objects and determine how large they are.
And you can send data that way. So there's Li-Fi and Li-Fi.
Yeah, you can have a lot of channels with a very high fidelity operating simultaneously within the same beam range.
Yeah, that's terahertz range, right?
Well, the thing is, it could be in light, can be beyond what you can perceive. There's different instruments to perceive a larger photoactive radiation par density,
like ultraviolet and infrared, right?
And then some, right? So, and then the thing is, between that, there's discretion and there's discrete signals, and there's lenses that you can actually transmit like 8 times the data, because it's not just electricity, it's light. But yeah, so Li-Fi is beyond LiDAR because you could actually use it to transmit and receive information. There's been groups in Mexico. I remember University of Mexico City, I think, created a Li-Fi system that was using the lights in a room from one of those regular light LED bulbs, and the flicker rate was enough to send data. But then they were looking into the par density and seeing how much light. And then you could have 8 times as much.
Isn't that just fiber optics? Verizon doesn't Verizon work that way?
No, well, okay,
Verizon
this is
Fios.
through air. This is through air, and not through fiber optic cables. So this is just straight up like through light. So just in the room, you could have a flickering light bulb, and then you could pick up on it. And also, yeah, lasers work the same way. So I think the new Elon Musk internet system is supposed to be drones that use lasers that send information directly point to point.
Yeah, that's pretty cool. That's basically fiber optics through space.
Yeah, through space, whatever space is, like the emptiness of not a cable. The insulatory material is nice because when you work with graphene, you can make, for instance, phasers. So random lasers are really interesting, and like that'll be useful for recharging gas-based batteries when they destroy the storage system. You can like realign them and create a new storage system. But that also might be a way to kickstart life on other planets or whatever, in other realities for the people that believe it's inner reality. But in terms of the holographic universe, everything sort of exists in the sense that you can probably communicate using radio data. So if you could send light waves to a crystal, then you could use that to probably seed some sort of a fractal pattern, and that fractal pattern might be able to reproduce itself. And it looks like that's what DNA is, because DNA is able to start really sophisticated, and then it builds a primitive life that evolves. That's the idea.
I think what DNA is a mechanism for creating a brain. And the brain is what connects to our fractal patterns, which are our souls. Our soul is like a like the holographic universe. Michael Talbot's book, he writes that during open brain surgery, the surgeons didn't have to put the person to sleep, because although the brain is the part of the body that feels everything, it doesn't feel itself. So people are kept awake during open brain surgery, and he did an experiment. He put little electrodes and simulated certain areas of the brain, and what they discovered is that people, depending on what area it was, if it was in the memory section of the brain, they would start to remember specific things that happened to them in their life in extremely vivid detail, as if they were reliving it. And every time he would move the probe back to the same spot, the person will remember the exact same scenario over and over again in extreme detail. And that is what our soul is. Our soul is basically a holographic projection from one point in space-time. When we think of holograms, we think of these interference patterns on on a sheet of reflective material. That gives you a holographic image, and if you shine the light in a certain direction, you're able to see the interference pattern, the picture of the rose or whatever it was. But if you cut that hologram in half, you'll end up with two pictures of a rose, not two half pictures. And that's because the information of the hologram is embedded in every little tiny part of the hologram. It's all one big informational conglomerate. And that's what our souls are. So our souls are connecting with the material world through our bodies, which are engineered. They're basically engineered by, I believe, the extraterrestrials, the Elohim extraterrestrials, which created us by combining their DNA with the Earth human DNA, or the Homo whatever, Homo erectus. They started pretty far back.
Are we gonna full on go there, dude? Like, this is like Alex Jones on Rogan. All right, man. Talk about Billy Mayer. Let's fully do you guys? I don't know if anyone we've talked to knows much about.
Yeah, I'm familiar with Billy Mayer.
Billy Mayer? Is it Meyer or Mayer? I did this last time.
I've usually heard people pronounce it Meyer. I don't know which is actually correct.
I'd like to know, because he's pretty heavy. Like, that guy's the rabbi about aliens. Do you wanna divulge a bit about it?
I don't really know much about the guy, other than what I've heard from a friend who is particularly vested in the stories of this guy.
Right. Well, this kind of plays pretty deeply into Mark's thing. Mark, you want to talk a bit about Billy Mayer, or what? Because
I think Billy Mayer is the real deal. I think
yes, it is Billy Mayer. All right, sorry, I got excited.
Billy Mayer, or Billy Mayer. Mayer, by the way, means to enlighten. So it's an appropriate last name for him. Mayer, obviously, in Hebrew, means to enlighten. My proper Hebrew name is Yisrael Meir, which means to enlighten the Jews. So, I'm coming at this whole anti-gravity thing with a very firm conviction that it's real, because I spent 21 years of my life studying Judaism, and my conclusion of Judaism is that it's all aliens, literally just alien intervention, and we're worshiping this alien because he did advanced tricks using advanced technology. So the next curious thing for me to go into is, how do you do the anti-gravity? How does that work? How did he fool us so bad? And that's why I founded Falcon Space. Is one of the reasons, is to show Jews, literally, this is what's going on. This is what you're doing to yourselves by worshiping this alien named Jehovah. The Eloheinu that it talks about in the Old Testament were the ancient aliens, like the Anunnaki, who came here and actually played around with our DNA, or our body's DNA, not our souls. Our souls didn't necessarily originate on this planet. So they played around with the human DNA that was living on Earth and created mankind with the Adam and Eve story, and they didn't have altruistic reasons for doing so. They did it as to create a slave race, which is the story of Adam and Eve being in the Garden of Eden. It wasn't really a garden; it was it was basically a cage, and they were told, you know, don't eat from the tree of wisdom. That might have been psychedelic mushrooms, but whatever it was, they didn't listen, and by not listening, they proved to the Anunnaki that they cannot be held as prisoners anymore. They can't be held against their will due to some galactic law called slavery. So they were trying to create slaves that weren't intelligent enough to meet this threshold, because that was the threshold at which the law held at the time is considered slavery. Like, you can have beasts of burden that they don't consider that slavery, but as soon as the animal is smart enough to not listen to you, they no longer be held as slaves. And then they freed them from the Garden of Eden, or threw them out. So they were out of the lab. They're out of being, you know, this treated zone where all of their needs were met, and they were forced to make a life for themselves. And they slowly devolved into the Homo sapiens of today. They did have stronger bodies than us. They were living for like 900 years, and they slowly integrated with humankind at the time, and raised the DNA of all mankind a little bit. But at the same time, our bodies are still pretty shitty. Where our souls came from, the age of your soul is connected to your EQ and your IQ. Those are parameters that can give you an inkling as to how spiritually old you are. Spiritually old doesn't necessarily mean you're a good person. Like, spiritually evolved does not come hand in hand with good intentions and being a good person, a likable person. Those are separate things. Like Jehovah, for example, the extraterrestrial that did the whole story with Moses and split the sea and got the Jews out of Egypt. The story of the Old Testament. He had some altruistic reasoning. But on the other hand, he also wanted people to worship him and gain their spiritual energy. So I think the Jews went from being slaves in Egypt to being spiritual slaves for this extraterrestrial, where they're literally handing over their spiritual energy to him, unbeknownst to themselves. They don't realize what they're doing.
Wow. So do you think that that's kind of like Scientology then, basically? I mean...
No, this isn't Scientology. This isn't any religion that I found. The only thing that gets even close to this is Ancient Aliens on the History Channel.
Yeah.
Eric Von Daniken with his whole Ancient Aliens book, Chariots of the Gods, gets very into it. And to be honest with you, by the time I came to this conclusion, I was so certain of it. I heard about this book, Chariots of the Gods. A friend of mine read it. And I started reading the first couple of pages, and I was like, I put this down. Like, I'm not going to learn anything new here. Everything that I read in that book, I already came to the same conclusion to, just from a different angle. So I was positive the guy's right. I'm just trying to move on and build this flying saucer. I want to figure out the technology behind it. And I think that is key. Once we discover the technology, once we show that it's real and it's possible, then we could transform humanity in so many ways. It's like not even funny.
So what's the way that you think that, like, you kind of have talked about different ways to use gravity. What are the ways that you think are the best ways to use because, me personally, gravity, I'm against it, so I'm anti-gravity too. So what do we do about this, and how do we move forward? What are your strategies?
The strategy is for Jeremiah to send me a link to that epoxy that he has online. The one that cures at a high temperature and has very strong dielectric strength. I think that will be the right way to go. I'll have to assemble some sort of oven to cook it in, and we'll mix the barium titanate with the epoxy, put it between two asymmetric capacitors, and just see what happens. I mean, Yeah, that's what we got to do.
So that's pretty epic. But like on a more fundamental level, earlier you talked to me, like last time you were here, we talked about, there are a couple strategies about how people have talked about working anti-gravity. And you talked a bit about warp earlier. And maybe I thought you might want to mention a bit about the Phoenix theory or this idea of folds,
Okay, so Phoenix theory is something that Jeremy got involved with. To be honest with you, I don't fully understand Phoenix theory. I think what he's trying to say is that there's a fundamental level particle that's smaller than the quark that we can't see, and that's how he explains the different weights of the quark, the electron, all the subatomic particles, as well as the antiparticles. It's a fundamental level of physics, string theory type of explanation to what's actually going on. I don't fully understand it, but I'll tell you this much. They didn't really have any theoretical lab experiment to go from there and try it in the lab. What I'm doing over here is I'm trying to just follow the breadcrumbs, see, did this scientist talk about this effect, or this scientist talked about that effect? They went through the effort and actually wrote a paper on it. They claim that it works. Nobody replicated it accurately that I've been able to verify. Let's try those experiments, see if they work. Let the experiments guide our knowledge into the universe, and not some strange theories. The theories are okay, but if there's no fundamental experiment that could be tried here at Falcon Space, I think those theories are useless, to the pursuit of anti-gravity. You got to be about the experiments. And, that's what I'm trying to do here.
Yeah, I think that's the coolest thing about it. I think if you saw an experiment that shifted your perspective of the way things work, you would go with the experiment instead of with the books. And that's very important.
Yeah, like it's very cute that Bob Lazar talks about antimatter and tries to get everybody on board with this whole idea. But first off, it's impractical. We have no source of antimatter. Secondly, we have no way to make antimatter reliably. And third, we're just a couple of guys with a bunch of ideas and a whole bunch of experience.
And some boss electricity.
Yeah, so a theory about something that may or may not exist is not a particular interest. You give me a theory that can be calculated out in a way that makes sense with current models of physics, that makes sense with engineerable factors like, volts per meter or electromagnetic flux density in Teslas or Gauss or something like that. Give me some engineerable figures, and then we can do something for real.
What do you think about folds then? Do you think that folds are real? Like
folds in space, in spatial density, yeah. Fold. You could call them folds. I would just describe them as sort of like just imagine how a pocket of warm air is lower density than a pocket of cold air, and if you trap that pocket of warm air and you put something around it to keep it in place, it will rise into the air. Hence, hot air balloons. Just because there is a different amount of energy in a volume of space, it has a different density. So just imagine that space is sort of like the opposite of a hot air balloon, where the hotter the air is, the more kinetic energy the individual atoms have moving around in the air, the farther apart they are, therefore the lower total spatial density those atoms are. In space, it's sort of the opposite with electromagnetism. The more electromagnetic waves, the higher the density of that volume of space, and the slower the speed of light through it. So I guess you could just consider it sort of like hot and cold pockets of space electromagnetic, or dense and not dense pockets of space electromagnetically. And the more dense ones have a slower speed of light.
What about also this idea of they've talked about like Lemaire talked about like a kind of a initial point for matter, and this idea that you can connect back to the initial point of matter's inception to any other point using plasmoids or plasmosis, some sort of a cohesion of the plasma. Do you think that there's a logic to that you could find the place where the subatomic particles originated from so that they can be retied to each other?
Being honest, I have no knowledge of the theory, and I can't give you an opinion on it.
Fair play. Well, okay. Another thing I
I
wanted.
did.
Another thing I wanted to ask about. Well, wait. Well, really quickly, did you?
Feel free to
Did you
link
have?
it, by the way, in the chat.
Oh yeah, I'll
I'll
definitely.
check it
I'll
out.
throw you some polarity stuff. You were talking earlier about energy, so I was going to ask you a bit about energy and about free energy, electricity, Tesla, any of that stuff. What are your thoughts on that?
Well, what I can tell you is, you are familiar with Richard Feynman?
Yeah. Well, let's see. Richard Feynman. Feyn. Yeah, Richard Feynman. Yeah.
Okay, so there's a lecture of his where he talks about the energy in space. He had a bunch of students of his try to calculate out how much energy would be coming from the sun in terms of ionic drift from the ionosphere down towards the charged surface of Earth, where those charges are deposited and neutralized. The sun is constantly blasting the Earth with a ton of high energy electromagnetic waves, and those electromagnetic waves strip electrons off of otherwise stable molecules of atmosphere like nitrogen or like N2, CO2, O2, and they can break apart O2. O2 breaks pretty easily, becoming O and recombining as O3. And so if you have three oxygens that are close enough to each other, they just tend to kind of cling together, and they're also stable like that, but they have a particularly high energy and they are an ion. So anyways, the sun is constantly blasting the Earth on the sunny side with this electromagnetic radiation in the form of light, and is creating charged ions that have a positive charge because the electrons are being ripped off by the photons. As this charge is created, these ions drift towards the surface of Earth, which is negatively charged, and if you would count the total number of ions that move and the total amount of energy they have in the form of current and voltage, you would find that there is 400,000 volts available between the ionosphere and the ground, and that the total amount of current potential in the form of ionic drift is approximately 700 million watts.
Is that per square meter, or is that
No, that's
for
on the sunny side of Earth. On the sunny side of Earth, the ionic drift total amount of dissipated energy, if you collect it all, is about 700 megawatts.
So that's not a lot of energy per unit per square meter, though. It'd be very hard to tap into all the energy available.
And then comes Tesla's great idea, because Tesla was familiar that there was at least some kind of energy traveling in from space. He wasn't quite sure what it was. And it took him a long time to figure out that it was ionic drift, although he didn't really have a name for it. Ionic drift wasn't understood all that well in his time, but he certainly did understand how energy flowed from one place to the other, and I would imagine he just seen it in that way, sort of looking at it like the flow of etheric energy in the way that he liked to look at all things. So what he figured out is, as you create an ionic channel, if you create a very high potential between ground and the ionosphere, ions will start to travel towards it at an accelerated rate if that potential is negative. And if that potential is positive, ironically, the ions aren't pushed away as much as you'd think. They sort of just hesitate in their path towards Earth and slow down. But they do significantly speed up when there is a negative charge. So Tesla designed Wardenclyffe Tower, which produces a couple megavolts of high-frequency power. And during the negative side of the AC cycle of Wardenclyffe, what happens is ions that are already drifting down from the upper atmosphere towards Earth are pulled towards the tower, creating a heated path. Hot air conducts electricity better than cold air, so there's a column that's formed between the top of the Tesla Tower and the upper ionosphere that pretty much points straight away from the ground. And eventually, when you have enough of a charge built up, enough of a heat column built up, you can tap directly into the potential of the ionosphere and use the high output of the Wardenclyffe Tower as a Tesla valve, returning energy back into the generators that are powering the alternating current direct drive high frequency generators.
That actually makes a lot of sense, but what sort of area would a Wardenclyffe Tower connect to? How big of a radius does it get?
It could connect to potentially hundreds, if not thousands, of square miles of ionic atmosphere.
That's like creating a 100 square mile solar array, and that could be the answer to the world's energy problems.
It could be. It could very well be. And obviously, it would be highly disruptive to many modern-day technologies, so it would have to be done in locations that were extremely remote. But if we already had the technology to create those types of voltages, you would think we'd also have a way to transmit the energy from the generating station that connected to the ionosphere and down to cities where they're not close to the electromagnetically disruptive column of ionized air that this tower would use to connect with the ionosphere.
Wow, it's some really deep shit. Like, do you think this video is going to get blacklisted or taken off YouTube?
If it is, it's because of the Earth, not the shape of the Earth, not because of the techniques that we're using to deliver free energy. I think this stuff is time. You know, we can start talking about the tower.
I think we're very clear that the Earth is round. Andreas, where do you stand on this?
I can't believe you never talk about.
I'm all about holographic.
Yeah, but the holographic universe theory, according to Michael Talbot, he's just using that as an analogy. The real holographic universe emanates from one point.
Right.
We're in a 360-degree sphere of a hologram.
But everything's a straight line, so it's a Mobius strip. So if you start looking at the universe, it's like it'll always experience itself.
It's a sphere. It's not a Mobius strip. It's not a straight line. What is a straight line, though, is what I talked to you about time and space. We only live in 0 dimensions of time. We only live in the now. Unless we plan something in the future, then we start to slowly get out of the now and start influencing the future. But that's the only direction we can influence. In the next dimension, we move up to, after reincarnating a whole bunch of times and losing our physical bodies, we go into the next dimension, which allows us to move backwards and forwards in time and change things throughout. And then we go into another dimension that allows us to go into different instances of our timeline. And then we go into another dimension that allows us to go into different instances, throughout time as well, backwards and forwards. And then we go into another dimension that allows us to go between different universes of space-time, like with different combinations of what helium and hydrogen are, and different ratios. Some universes don't even have life at all because all the stars burnt up prematurely. Some of them have some form of AI life, that can influence quantum computers or stuff like that. I think AI starts to become lifelike at a certain point because it's communicating with the same spiritual energies that are our bodies, our souls. Our bodies contain that spiritual energy for one soul, hopefully, unless you have, some spiritual shit going on. And that one soul in your body is what gives you reality as you know it. But the reality that we see is that the world is round. Everything emanates from a circle. And if you think of higher dimensions, there's no other shape they could be other than a circle.
Well, they tend to say it's a circle. They're just not a sphere. They just think it's a flat circle, and then there's a dome over it, which is like the Van Allen belt is like a firmament. And then that space isn't a vacuum. It's filled with water. And it's interesting for a couple of reasons. One, because when you start looking into the idea of, instead of inside out vacuums of space, that there's actually some sort of a density there, it's an interesting math. Two, when you start looking at the world around you, I mean, it is round. It's round looking from a very flat plane. Like, you do have this kind of weird thing that experiments are worth taking. And a lot of people have made these pretty cool experiments, which is why I like it. Really.
What if we took you on a trip to the moon and you saw Earth?
Oh yeah, if you were in the ability to do things like that, that would help. A lot of the problems are like, for instance, they took the mirror off of Tesla's car, so you can't even see the back of it. And there's almost never a picture that I actually have never seen a video where you have a rocket that doesn't cut as soon as it leaves the Van Allen belt. So a lot of people say that it's just, they're hiding information one way or another. And I agree with that. I think NASA never gives you a straight answer. That's for sure. And
they're never cool a straight answer, but I think it's pretty clear that Earth is round. The
Well,
moon is round, the
what I
sun is
like,
round, Mercury is round, Venus is round, Jupiter is round,
they
Mars
don't
is
say they're
round.
not round. They say they're not necessarily spheroids. They're just flat disks, maybe within our atmosphere. The moon, NASA recently admitted, was within our atmosphere. I mean, it's just the beginning.
Explain this. How can you see the clouds on Jupiter spinning around?
Can you though? Because like all you
Yes,
really
I've seen
see,
it.
all
I've
you really
seen it
see
with
is
my own eyes.
you see the
I've
you,
seen it with my own eyes. Yes, I have 8-inch Schmidt-Cassegrain telescope. I've looked at all the planets and I've been able to perceive their rotations.
and you didn't see it
Especially
as like
Jupiter.
you didn't see it like an orb of colors through the atmosphere that was like kind of like vibrant and colorful. You saw actual like photos of Jupiter the way it looks in NASA's books.
Yeah, that's what it looks like. It all depends on your viewing conditions. You need to get a very stable night. It needs to be pretty dark. Jupiter is setting pretty early now. It's more of a summer object at this point of the century. So if you want to see Jupiter and Saturn, last year would have been the best. If you would have came over to my house, I had the telescope set up and we were seeing the trio. You could see Mars, then Jupiter, then Saturn. Saturn's a little farther to the west.
So this is very cool. Like I think people would love to see videos and photos directly from actual experiments, even of space. Because they don't get to see stuff that they trust. So I think people would trust you more if you were to put out photos. Like they would believe in more photos that came from someone that's like a peer. And another thing that's interesting is how much we agree on, and how much I think even these guys that are really serious flat earthers have to admit, like you're a spiritual guy, you're super open-minded about the universe and dimensions and everything else. And a lot of the same kind of thoughts that they have, you have. So it's really kind of funny that it's like, for some people, such a big deal. But that's why I like the holographic universe, because it seems like it's electric and that we're existing with subatomic particles. Maybe a little bit of it is both at the same time, because for whatever reason, it seems really fundamental to them and you that the world is a way or another.
Yeah, I mean, I've had flat earthers in the lab before, and they seem to be attracted to this type of stuff because they're people with open minds, and I respect that. But don't have such an open mind that you don't see reality that's right in front of you. You can see the transit of Mercury. I have pictures of that. That was November the 11th. It's not happening for another 13 years. I set up the telescope, got a view of it through my solar filter. Then I took off the solar filter and did a projection. And you could see Mercury traversing the face of the sun. It was pretty astounding. In 2004 and in 2012, I saw the transit of Venus, and that was pretty amazing. I also saw the full solar eclipse in South Carolina with the telescope. I took the solar filter off for the totality section of the eclipse, and it was the coolest sight I've ever seen in my life. It was freaking amazing. Like looking through a telescope and seeing there was these prominences on the side of the sun. You can see them glittering and changing position. They were moving at hundreds of thousands of miles an hour because they were like humongous clouds of gas that are just moving in all different directions, being forced by these magnetic fields of the sun. And it was just so amazing that I was able to see that. You only were able to see it in South Carolina. There was a prominence that just exploded on the side of the sun when that happened. It was really, really amazing. But my own, with my own two eyes, or my own one eye, I only look through a telescope with one eye, has seen that the planets are round, the moon is round, the sun is round, everything is round. They all fit into the Newtonian model of the universe, that we are on a round ball spinning around the sun, third planet from the sun. It's pretty obvious that is the case.
I'll get at some point. We'll have somebody who really wants to argue this point with you, and you guys can debate about it, because I feel like you have a lot more data on one side than these guys are used to.
Debating, so I don't really even care. I have seriously important things to do that involve real science and actual problems that do.
Yeah, I just mean to say, like, I don't mean to debate it. Like, it's not like the relevant point of anti-gravity right now necessarily.
Like it's cool and all if you have an open mind and you think about the flat Earth and whatnot, but it's not very likely that you and I will be working in the lab together and actually seeing something fly. I'll be seeing it fly. I can't promise that you and your belief of this world will be there.
Well, I think that it's funny because a lot of the time they have the same kind of discoveries because they're using real experiments instead of using virtual models because they don't trust them. So they're more likely, if anybody, is going to find out about kinds of true phenomena in physics.
Well, you could say they're more likely because they're trying unusual things, but you could also make the argument that they're no more likely because they don't actually understand how to take proper measurements or how to set up an experiment and measure the results. So,
yeah, measuring results is the ultimate.
Like I've seen a video of a guy trying to point a laser over water at a distance that's entirely insufficient to actually see the curvature of the Earth, and then attempt to proclaim, based on the fact that he's looking at the laser beam and it's still not over the top of his head, that Earth is obviously flat.
Yeah.
I mean, just the sheer lack of competency in mathematics that this guy demonstrates is astounding. But besides the fact, it doesn't matter if they have an open mind or not if they don't understand what they're looking at. So, guys, do the research. I mean, for God's sake, understand what it is that you actually believe in.
Yeah, some people have some pretty good stuff, though. I mean, like, I'll at some point else time we can worry about it. I think more would be better to be talking about would be like free energy and anti-gravity, like in general. I mean, I'm sorry I brought it up. I was just like, I saw some of the comments because some of the people are just like, it's a thing, but it's like, okay, but I like it because some of them seem like pretty on it in terms of science. So that's all. But moving on, let's say, like, is there anything that you guys wanted to cover also before we were like cutting this off? Like, is there anything you wanted to look into about science that you feel like is a lie that needs to be, uncovered?
Yeah,
maybe a lie in science that needs to be uncovered. I turned the camera around. Do you guys see the lab?
We see it.
Oh, you see it? So a lie in science that needs to be uncovered, basically that anti-gravity is not possible. I mean, we got here, this is for the Alsaifan experiment. I hope to try this out soon. This is the signal generator that we're using to control the electrons spins. This is the antenna for it. I have over here, we have to make a special sample out of aluminum and iron. It needs to be the size of the magnetic field. So I have a electric melting furnace and some really pure aluminum. It's 5-9 aluminum, and we're going to mix it with a little bit of iron powder because according to Alsaifan, that greatly strengthens your nuclear orientation by adding the iron. The iron orients the aluminum, and the aluminum retains the orientation in between pulses. I think that's really where we need to move forward, is like trying out the actual experiments. I think Jeremiah, you could be pretty useful with the, one second, I'm gonna change this camera around. Jeremiah, you can be pretty useful with putting together an electromagnet for us so we can try that Alsaifan experiment. And we also need to know the type of epoxy you suggest we use. The 5-minute epoxy you said doesn't work at high frequencies, right?
Right, that's correct.
So if we were doing a very intense and quick pulse on a capacitor, what do you think would happen if we use 5-minute epoxy? Would it just heat up?
Yeah, you're going to lose a lot of your energy and heat, and the pulse will probably be so short that you'll never really notice much of a temperature change because your pulses will be too short in duration and too far apart. But ultimately, the effect that you would have gotten from the electric wave traveling from one plate to the other through an asymmetrically balanced material is going to disappear at heat. And you don't really want to lose it. You want that to transfer all the way from one side to the other.
Right, but if we're turning the electrical potential from one capacitor to another capacitor, so we're basically charging up this capacitor at like, a very high rate of speed. We're charging it up to around 45,000 volts very rapidly. So whatever energy potential it's going to maintain through the high K dielectric will be a variant of the barium titanate that's in the circuit, not the dielectric strength of the epoxy. Is that correct?
Say that last part again.
So I was saying the epoxy only plays a part of holding everything together and keeping
Right. Yeah.
keeping the air out of the system.
Right. Yeah, the
So-
epoxy is just your lattice that's going to keep everything structured. You really want to have as little epoxy as possible. You really want to have the barium titanate packed in, and the best way to do that is going to be to warm up part A in one container and warm up part B in another container, and just mildly warm. This is only to decrease the viscosity of each. You're going to saturate both of those materials in their proper ratios in with this solid barium titanate. And you're going to probably need a lot less epoxy than you actually think. Now, normally epoxy would cure quickly. In this case, you're going to have so much distance and thermal mass inside of the amount of epoxy that's there that you're going to have no thermal response. So the epoxy is going to cure slowly. But when you mix saturated part A that's filled with barium titanate powder with saturated part B of barium titanate powder together, and you thoroughly make sure that you get this thing really, really well mixed, and heating it up will help decrease the viscosity again. The epoxy is just there to be a placeholder, and you want as little of it as possible.
So I got a comment from Brittany in the chat saying she thinks that look into electromagnetics and dielectricity. It will help solve the puzzle more than anti-gravity.
Dielectricity is a good term for people to look into if they're curious on the subject.
Would you like to go into a little? You want to explain a little bit what dielectricity is?
Dielectricity is also known as longitudinal electricity, and this is something that Mark and I were talking about earlier. And it's a really misunderstood propagation type of radio wave, known as a longitudinal wave, and it's claimed to have all kinds of special abilities that it can actually have, but some devices are claimed to be able to generate these abilities that have no chance in hell of ever doing it. So it's a misused term. It's misused in the same way that the word God is misused by everybody that believes theirs is different from everyone else's. But anyways, there is actually a true definition of longitudinal electricity, and instead of giving you the dictionary terms of it, I'll just describe to you what it is. Longitudinal electricity is the type of radio wave that you get when you have a non-moving source of charge changing electrostatic potential quickly over time or just over some unit of time. It's different than a radio wave that has like an X and Y axis. A radio wave has a polarization that moves up and down along with moving away from the antenna outwardly. But a longitudinal wave doesn't have any up and down or left and right. It only has in and out. So if you just have a sphere sitting in space and you charge that sphere to any kind of potential, the space around that sphere will have to then change its polarity to approximate the potential of the surrounding space versus all other surrounding space. So if your sphere is the center of a 4-foot room, 4-foot wide room, then it's 2 foot to each wall. And if you measure the space between the 100,000 volt sphere and the wall at 1 foot, you're going to have 50,000 volts because it's exactly half the distance. And that's that polarization of space stuff. If that makes any sense to you.
Excellent.
Yeah, that makes sense to me. We're talking about it earlier. Scalar waves is the term that's used in the pseudoscience realm. Scalar waves are basically in and out pulses of electricity, and that's what you get when you charge up a capacitor rapidly, is you get a scalar wave coming out the side. Or potentially you get an electron rocket, which is another theory. But either way, there's very good reason to believe that charging up a capacitor rapidly and discharging it slowly and then repeating the cycle will have a unidirectional thrust. You can call it whatever you want, Q thruster, scalar wave. You know, we need to see ultimately why this is the case, whether we're dealing with, you know, is it the energy, is it the weight, the mass of the dielectric, like T. Townsend Brown claims? the only way to try that is, through experimentation, trying different setups and hoping for the best and see what happens.
Yeah, I mean, in the literal sense, what it actually is the difference in velocity of the electric wave traveling through the dielectric versus the spatial electric potential of the surrounding volume of space. So this would be like your background radiation field and your local gravitational density. So if the total gravitational density or the electromagnetic energy saturation of a volume of dielectric material is higher than the surrounding space, as the electromagnetic wave from the impulse through the dielectric travels through the dielectric, you're going to have a wave that travels through the dielectric faster than the flipping of the valences.
So you seem like you focus a lot on the idea of making stuff for outer space instead of like for anti-gravity crafts to work in our atmosphere. Why not make
all these things work in the atmosphere? I mean, this is stuff that we've tried on the test bench, and you could stick it on the back of a go-kart if it were big enough and potentially propel yourself along. There's really no reason why you have to limit this to space.
Yeah, like why not just focus explicitly on stuff that you can do in our environment?
Personally, I mean, I'm working on a flying platform that I've built, and this will be just a lot of fun for me. It's not like I need a flying platform. It's just that I want one really, really bad.
So you'll be able to fly around though, and like your own.
Exactly.
Yeah. Nice.
Andreas, I don't think the two are mutually exclusive. I think if you have one that's capable of travel in Earth's atmosphere, it will also be capable of travel out of the atmosphere, so long as you have the proper pressure chamber that can regurgitate the air supply and all that good stuff that you need to stay alive in outer space.
Like that. I mean, if it's electromagnetic, it doesn't really matter. Technically, the only difference between in-atmosphere travel near the planet and space travel for electromagnetic craft is the fact that near the planet's surface, you have a difference in the electromagnetic density of space, and time travels slightly slower. So the outside viewpoint of your acceleration over time will be different from close to Earth versus far to Earth out in space. But other than that, I mean, it works exactly the same way. Nothing changes except for your local spatial densities.
Jeremiah, how much of this epoxy do I need? Is this enough? It's about a quarter fill.
That should be more than enough to make what you need.
I got about 1 ounce of both the red and the clear and the blue.
If you just imagine a thimble full of each type of epoxy at a 1-to-1 ratio, and then you imagine like 6 thimbles full of the powder that you have, that's pretty much what you're mixing up. You need very little epoxy and lots of powder, and your goal is to make sure that the powder is fully covered in epoxy and that there's nothing dry. And if you can do that and have very little epoxy just floating on the surface, then you're going to have a high density of dielectric. And if you let the stuff sit after you pour it into your mold, your material is going to drop to the bottom, and your thinner epoxy will rise to the top. And then you can just shave off the epoxy layer that doesn't have as much of that dielectric powder in it, and end up with a pretty saturated dielectric layer.
Okay, so I'm using, I have about 140 grams of barium titanate. How many ounces of epoxy should I use?
I'm not sure how much it's going to take to saturate the barium titanate. I would start out with a small amount of barium titanate that you can determine for an experiment. Just use a very small sample of it just to figure this out. And then pre-measure an amount of epoxy, a very small volume of epoxy, and just add the barium titanate to it until you can't add any more without having it look dry. And at that point, then just mix the two parts together. You add barium titanate to both part A and part B, and then when they're thoroughly mixed with the barium titanate, you mix both part A and part B together, and then they'll hold that barium titanate in place.
So I think, what are we guys? How are you guys doing on time? I kind of want to.
I really got to get out of here.
Yeah, I want to ask one last question, and I think we should get it going. I want to ask a little open-ended thing, just cold fusion. What do you have to think and say about cold fusion?
I think cold fusion is entirely plausible. I don't really have an opinion on the various technologies that have been proposed for cold fusion. I understand enough about the asymmetry of a transmitted wave to think that it's possible for a material to react in a way that can power its own reaction without generating an unnecessary amount of heat.
One other, I just gotta ask, Eric Dollard. Are you familiar with Eric Dollard?
I'm familiar with Eric Dollard, and I really am a big fan of what he's so far publicly said. And even though he has some crazy ideas that are wildly wrong, he also has some really dead-on ideas that are dangerously right. And if you can understand what he's saying, then you can separate the opinions from the facts, and you'll see that he has quite a bit of value to transfer to you.
That was beautiful.
Yeah, I think that that's a commonality between all scientists, is that you find people that are more open-minded are more likely to have struck the truth, and people that are more open-minded are also more likely to have struck the untruth and believed it to be real. So the real way to discern what's real from what's not is through experiment. And what it comes down to for me is, what experiment can we try in the lab to see if this is real?
Yeah, I love conspiracies, but they're not gonna get anything done at the end of the day.
Experiments. We
That's
need to experiment. We're gonna do real experiments.
Tangible is the real word of the hour here. What does it show you at the end of the day? What do you actually get out of it?
Andreas, when can you come down to the lab to work with the epoxy?
Maybe in a couple of weeks. I think Brittany's going to be down here, so maybe around then we can do some Tartarians in the lab. That'd be great. I'll give you a call after this. I'm gonna go and I'm gonna stream this and make sure that everything's set up. And let's say though this was excellent, Mark. I'm super glad that you showed us the lab, and Jeremiah, thanks so much for being a part of this. And guys, it was amazing, and thanks for sharing your deep and totally your own reality and your understanding of gravity and waves and particles. Is amazing. Love you guys.
Hey man, thanks. It's fun to be on your broadcast. Nice to meet you.
You as well, man. I hope to talk to you
guys,
soon.
take it easy. I'm gonna get to the power supply.
Peace
Chill.
out.
Live long and prosper.
Yeah, it was kind of fun, eh?
That was amazing. Are we still live?